Okay, good evening. Tonight we're going to be looking at how to graph a rational function. Now, when we're looking at how to graph a rational functions, there's several different steps that we're going to be looking at. There's going to be 9 total steps that we're going to need to take care of. Now, when we take care of each of these steps, not all of them always apply to every single graph. We have to kind of use our reasoning skills to determine, okay, do I need to do this step or do I need to do this step? So the first step that we're going to do, and this is going to be a new one this year, as we did not do this last year in Algebra 2, is we need to determine any x-intercepts. And the way we determine if there is an x-intercept is we will set the equation equal to 0 and solve for x. The second item that we need to take care of is we need to find the y-intercept. And the way we find the y-intercept is by substituting 0 for x and solving for the y value. Now, there is a little bit of a note I would like to make about finding your x and y intercepts. The x-intercept, you could have 1, you could have more than 1, or you may even have none if the function is undefined when x is equal to 0, or if the function never crosses the x-axis. The second type with a y-intercept, you could have none, or it could have 1. Okay, if the function is undefined when x is 0, then we're not going to have a y-intercept. Okay, so those are 2 new things. Then last year, step 3, everybody should be familiar with this. We're going to determine if there are any points of discontinuity. And we're going to start by looking if there are any holes. And so the way we determine if there are any holes is if we factor the equation, both the numerator and the denominator, if we have a common factor that will divide out. The denominator factor and numerator factor that cancel out. The fourth step is something that we did last year, was determining if there's any vertical asymptote. Where is the function completely undefined? And the way we're going to determine a vertical asymptote, and when I'm writing vertical asymptotes, same as last year, I'm going to abbreviate it as a VA for vertical asymptote. This is going to be caused by any values that are left over in the denominator when they are equal to 0. The fifth item is we're going to determine a function's end behavior. So the way we find the end behavior is based on the horizontal asymptote. And we have 3 rules that we have to know for the horizontal asymptote. I'm going to be abbreviating these as HA. So the first thing is we have y is equal to both the limit as x approaches positive infinity of f of x, or the right side end behavior, which is also equal to the limit as x approaches negative infinity of f of x, or our left end behavior. We have 3 rules on how to calculate these limits, as well as how to just summarize our horizontal asymptote. The first rule is what we call Betsy. If we have equal terms, we're going to look at the coefficients. So if I'm looking at, say, 5x to the 4th plus I don't know what else, and then over 3x to the 4th, and 5x to the 4th and 3x to the 4th are both the leading terms of those 2 polynomials, then we're just going to look at these 2 leading coefficients. So this would be y is equal to 5 over 3. Our second type Our second rule is Bobo. If we have a bigger exponent on the bottom, it's equal to 0. So if our leading term is larger in the denominator, so say we had 5x cubed this time over 3x to the 5th, okay, 5 is larger than 3, then what we would be able to automatically say is y is equal to 0. The final type is BOTU. If the bigger exponent is on top, it's undefined. So the limit as x approaches infinity, and let's say we had 5x to the 5th and a bunch of other terms, but 5x to the 5th is our leading term. And we also had 3x cubed in the denominator and a couple other terms, so it's a cubic function in the denominator. We would not have a horizontal asymptote. This would be undefined. There is no horizontal asymptote. Now, one thing new this year, last year we said that there was no horizontal asymptote. This year we're going to be able to add in that we have something that's called an oblique or slant asymptote. So our sixth step that we need to check is we need to determine if the graph ever intersects the horizontal asymptote. Now remember, the horizontal asymptote is only talking about its end behavior. So it doesn't say anything about small finite values of x. It can cross the horizontal asymptote in the middle of the equation, in the middle of the graph, but when we get farther and farther out on both the left and right sides, it will kind of just even out with our horizontal asymptote. Now 7, this is what you have to do if you end up where it's BOTU. Okay, you need to find your oblique asymptote or slant asymptote. And the way you will find the oblique asymptote is by doing synthetic division. And you're going to actually reduce the polynomial or reduce the rational function. After it's reduced, then we're going to start by graphing that. Okay. The next item we did last year when we had multi-asymptote rational functions. What we're going to do is we're going to plot 2 points that are arbitrarily close. The closer you get, the better to your vertical asymptote. From either side. You do need to check both sides of your vertical asymptote. The final step that you're going to do is you're going to kind of connect all the dots. You're going to stay within the lines of your asymptotes to complete the graph. So to recap, first thing that we're going to do is we're going to determine if there are any x-intercepts. We could have one, we could have more, or we could have many, or we could even have none. And the way we're going to do that, we set y equal to 0 and we solve for x. The second item that we need to complete is find the y-intercept if it exists. We could have none, or we could even have one. The way we find our y-intercept is we substitute 0 for x, solve for y. The third item we're going to do is we're going to determine if there are any holes in the graph. Remember, a hole is caused when a denominator factor and a numerator factor cancel each other out. And so whatever would turn that factor into 0 is what would actually cause the hole. Fourth item, find your vertical asymptote. Any leftover factors that remain in your denominator, those are going to cause a vertical asymptote when they are equal to 0. Step 5, you're going to determine your function's end behavior. So what happens on the far left side and far right side of your graph. If you have equal terms, equal degrees in the numerator and denominator, we look at the leading terms. Equal terms, we look at their coefficients. Okay? If it's bigger on bottom, y equals 0. So when we had 5x cubed over 3x to the 5th, we had y equals 0. Our final one was it was bigger on top. It was undefined. So the limit would cause it to actually be undefined. And instead, we're going to skip over to step 7, where we find the horizontal, or we find an oblique asymptote by doing the synthetic division. The final steps, we're going to determine if the graph intersects the horizontal asymptote. So what we would do is we would set the equation equal to whatever the horizontal asymptote is, solve for solve for x. Okay, if we ended up with BOTU, where it was bigger on top and it was undefined, for the horizontal asymptote, we will find the oblique asymptote, or the slant, using synthetic division. We're going to choose 2 points that are close to the vertical asymptote on either side, if we have a vertical asymptote. In 9, we're going to kind of connect the dots, make a completed graph. Okay, the next video will have some actual physical problems for us to work out.